let's see the another topic here, first law of thermodynamics. So today we are going to discuss about first law of thermodynamics. Last class we have discussed about internal energy, heat. If you didn't see, just go through the playlist and look at that. So now, if the quantity of heat supplied to a system is capable of doing work, so that means I have one system, one container of conducting wall. It's both are non-conducting walls, bottom will be conducting, so that I am giving heat to here. Here will be, there is a piston which is a movable piston. Okay, it's a movable piston and it is at position A. Here totally gas is there. Okay, that gas internal energy is U1, and here I am giving heat energy, that is delta Q to this. Okay, clear? Right. So what is the total energy here? U1 plus TQ. So this is the total energy which is presented initially. Now what will happen, then the quantity of heat absorbed by the system, so we are giving heat energy, no, that is absorbed by this, that is equal to the sum of increase in internal energy. So here what will happen, initially the energy is U1, now the energy is going to be increases, so that this gas is going to do some external work. So when you are increasing the temperature, what this gas will do, gas will expands, that means the piston will move above. So initially this is the position of piston, now this goes to this position B. Okay, clear? Right. How much distance it travel, let's consider it travel dx. So how much work it will be done, dw work it will be done. Okay, now what will be the energy of it, it's a u2, just consider it is u2. So initial internal energy u1, now this internal energy u2. Here before, the energy given is dq, so that because of this internal energy it has done some work. Okay, that means, so initial energy will be equal to final energy. Final energy is what, u2 plus dw. So according to the law of conservation of energy, initial energy will be equal to this final energy, so that u1 plus dq equal to u2 plus dw. So u1 you can take that set, so dq equal to u2 minus u1 plus dw. So dq equal to u2 minus u1 will be written as change in internal energy, so du plus dw. So this is the first law of thermodynamics. So dq equal to du plus dw. Clear? So this is the mathematical expression for first law of thermodynamics. Okay, see next, how these sign conventions dq, du and dw, here there are different sign conventions are there. So let's take again the container what we have initially. So this is the piston, it is at position A, and here is the gas, and that energy is U, and here what you are giving, heat energy we are giving, that is dq, or you can write as delta q, anything you can write, there's no objection, fine. So that what will happen, this is gone upwards, has been moved to position. So what will happen here, work is done dw or delta v, delta w. Here you can write as dq or du or delta u, anything you can take, no problem. See now, first work done, now you are, what you are giving, energy you are giving, heat energy. So heat energy you are giving, no, so heat energy added to the system is positive. Okay, heat energy added to the system, system means what, to the gas. Okay, so here added, now heat energy is going to be released, will be taken as negative. Okay, that means you are, it is released. Okay, that means here heat energy will be positive, that means plus dq. Here heat energy will be minus dq for heat energy. Okay, now check for work done. What about the work done? Work done by the system and work done on the system, that means work done by the gas, work done on the gas. Now because of this what will happen, this piston is moving upwards. Okay, clear? So work done by the system, what it will do, it is doing work so that it is moving upwards. So work done by the system is positive. Same direction, work is acting in this direction, displacement also in same direction, so work done is positive. Next, work done on the system, will be negative. On this force is acting, piston is acting on it, piston weight is acting on it, but even though it is moving upwards, right, force is acting downwards but this piston is acting moving upwards, so force and displacement are in opposite direction, so work done is negative. Clear? Right. Next, internal energy. So change in internal energy. Internal energy, for example, when you are giving heat energy here, what's happening? The energy will be increases. So increase in internal energy will be taken as positive. Okay. Decrease in internal energy will be taken as negative. Okay. These are the sign conventions for heat energy, work done, and internal energy. So plus dq minus dq, this will be written as plus dw, this will be written as minus dw, and this will be written as plus du, and this will be written as minus du. So this is the total energy sign conventions: work done, heat energy, and as well as internal energy. Okay, clear? Right. Next, significance. What are the significance and limitations of third law, first law of thermodynamics? First one, it introduces the concept of internal energy. It is applicable to all states of matter. So in this container we are giving some energy to the gas, so what it is representing? It is representing about internal energy. It is applicable to all states of matter, it's not only for gas, it may be for solid as well as for liquid. All the cases this total energy, first law of thermodynamics, acceptable. And what is the limitation here? It does not give any information about the direction of heat flow, from where to where the heat is flowing. When two bodies, what two bodies? Hot body and cold body. When two bodies are in contact, from where to where the energy is transferring, it does not give that. Okay, clear? This is about simple first law of thermodynamics. So what is the formula? Delta Q equal to delta U plus delta W. Okay, here all are positive. See, heat energy work done, heat energy taken, and heat energy internal energy increases, and the work done by the system. Work done on the system means it is negative. This is by the system. Work done on the system means delta U minus delta W. It is on the system. Okay, clear? So this is about law of thermodynamics. Let's see your two problems on it. So when heat energy of 1500 joules is supplied to a gas, the external work done on the gas is 525 joules. What is the increase in its internal energy? So here heat energy given, heat energy is delta Q, that is 1500 joules. It is supplied. Supplied means given only, no, given means the system is taken. That means gas is going to take that, so it is positive. The external work done on the gas, work done on the gas is positive or negative? Negative. By the gas is positive, on the gas is negative, that is 525 joules. What is the increase in internal energy? This is what they asked. According to first law of thermodynamics, what it is? Delta Q equal to delta U plus delta W. So what is the delta Q here? 1500. Delta U is don't know, minus delta W is 525 joules, plus into minus minus. Okay, so delta U equal to 1500 plus 525. When 525 comes this side, then it will be plus 525. So then the total internal energy is 1025 joules. Okay, this is the internal energy. Okay, next, when 1 gram of water at 100 degrees Celsius is converted into steam at same 100 degrees Celsius, it occupies a volume is so much? 1671 cc. Okay, 1671 cc. Initially it is 1 gram, so it is V2, and V1 is 1 gram. Okay, clear? Right. So 1 gram of water, so that means it is 1 cc. 1 cc means how much it is? 10 power minus 6 meter cube. 10 power minus 6 meter cube. Okay. And what about Vt? V2, it's a 1671 into cc. Cc means how much? 10 power minus 6 meter cube. So that is V1 and it is V2 at normal atmospheric pressure. What is the normal atmospheric pressure? 1.013 into 10 to the power of 5 pascals. Okay, clear? Right. Or Newton per meter square, both are correct only. So find the increase in internal energy. They ask you to find increase in internal energy. So increase in internal energy is nothing but this is V1, V2 and P we have. So change in work done. Change in work done equal to PTV. So change in work done equal to PV, work equal to PdV. dW equal to PdV. So from this dW equal to, here work done not there. What is the pressure? 1.013 into 10 to the power of 5 pascals into V2 minus V1, that is 1671 into 10 power minus 6 minus this. So it is 1671 into 10 to the power of minus 6 minus 10 power minus 6. Okay. So this will be written as 1.013 into 10 to the power of 5 of 167 in this. Can I take 10 power minus 6 common? So 1671 minus 1. So it is 1670. So it is 1.013 into 10 to the power of minus 1 of 1670. Okay, if you multiply this with this, then we will get 1.013 into 167. Okay, so after multiplying these two, what you will get? You will get it is 169.2 joules. So this is what we will get as work done. Okay, clear? Work done. So now we got work done and we need to find the increase in internal energy, delta Q. Okay, so it is nothing but delta W. According to thermodynamics, first law of thermodynamics, delta Q equal to delta U plus delta W. Delta W, okay. What about delta U? We need to find it out. What about delta Q, heat energy? What about the heat energy? It is converting heat energy. When 1 gram of 100 degrees Celsius, it is converted into steam. So when it is converted, what is the formula? Delta Q equal to M into L, mass into latent heat. Okay, how much mass it is? 1 gram. Okay, so 1 gram into, what is the latent heat? Latent heat means how much it is? So specific heat, latent heat of vaporization of steam, what is how much? It's a 540. Okay, 540 calorie per gram. Okay, wow, clear? So it is 540 calories. 1 calorie equal to how many joules? It is in joules, no? So this also should be in joules. So 540, 1 calorie equal to 4.2 joules. So after multiplying these two, how much you'll get? So 2268 joules. Okay, so delta W and delta Q we know. So can we find the delta U? Right, we'll see now. So delta Q equal to delta U plus delta W. So delta W is 1692, delta Q is 2268. Delta Q is 2268 equal to change in an internal energy don't know, and delta U is 169. Okay, let's write 169. Okay, so delta U equal to 2268 minus 169. So how much 2268 minus 169? It is 2099 joules. Okay, so this is the change or increase in internal energy of the system. Okay.